This video deals with reviving instrumentation using DAC2Go, and it provides an overview of the process. There are a significant number of instruments that we call dead instruments. They basically are really quite good hardware, but which the electronics or software has finally given up the ghost. These are expensive instruments, but they, until recently, have been very expensive to fix. Now, part of the problem with the broken electronics is usually poor documentation from vendors. Parts are hard to find. They're expensive. Sometimes the problem is impossible to find, and there's usually no more vendor support. The software, there's lots of problems. Usually it's just that the vendor provided custom stuff with no access, poor documentation, or the operating system is now obsolete and the IT departments don't want it around, or the instruments on which, the computers on which they were have died. And so sometimes the whole software is missing and it simply needs replacement. Now enters the idea of using DAC2Go, which is a system integration concept, and it leverages good electronics and software together so you don't need an electrical engineer or programmer support to make a fully integrated instrument system. And fundamentally, its idea is shown here on the screen. Basically, a USB port accessed board and software that's resident in the Windows operating system. So how do you go about doing it? You keep the basic instrument because usually the hardware is really good and it's just the electronics and software that are bad, and the strategy is usually just to replace them. So you first off define what the fix is, what to keep and what to replace. Install new electronics, for example, and a controller, fit the instrument with a new personality, copying the valuable features for operating onto the new software, and add improvements. You can also upgrade the performance, like increase signal to noise, use other sensors, add automation, and so forth. So the first thing you have to do is define for each of the actuators, in other words, fans, pumps, motors, whatsoever, what needs to be controlled, defining how to control it. Then stepwise, once you've done that, connect it appropriately to DAC2Go and test that each item works. Then you go looking for the sensors and detector signals and connect them appropriately. Finally, you define the instrument personality you want to use in software and then test the thing, starting, of course, with safety and then functionality. So what are the signals? There's lots of them. There's power, there's control inputs, there are feedback for control, there's information, metrology kind of signals, communication signals, and they can be analog, digital, frequency, current, and so forth. Here shows how you'd connect actuators, like, for example, valves for pneumatic actuators, for example, an injection valve. Here's another one that shows an actuator like a GC door, very similar. We also connect items like the gas flow controllers, and you can just look to the OEM documentation and connect them properly. Sometimes you can add extra features that weren't there, that the vendor for the instrument that you have didn't provide, but it's there. Temperature controllers, DAC2Go, can sometimes replace the whole temperature controller. Or you can find the sensor that's used and connect it up or communicate with the existing controller. This is kind of how normal high loads are connected. They're usually connected through a relay, which is turned on and off via the digital output port from DAC2Go, and any size load can be handled once the proper wiring and suitable relay is chosen. Here's an example using a modest-sized motor and DAC2Go being controlled by digital output port, and you can see that the power is completely separate from the instrument and from DAC2Go. This is another one that shows connecting items with power modulation, and by that I mean a device like a DC motor that you want to change the speed of programmatically. And So this is how it can be readily done. This is one example of many. The signals can be connected, and there are well-marked places on the boards to connect all of the signals, and this shows an example of it. Where you don't have connections on the board, you can connect through RS-232, USB, or 485 adapter ports to communicate with objects that require script. Once you have the connections done, you then turn around and want to use some software. Well, DAC2Go provides several different kinds of workbooks just for the purpose. There's a GP DAC, there's a GC workbook, HPLC workbook, GPC data system workbook, and a mechanical tester work. You can look at the YouTube videos, search term DAC2Go, and there you can see lots of information. You can also go to the website DAC2Go for details.